Hello, my name is Giacomo Luvisutti from the University of Udine, and today I will talk about the raw material, power consumption, burners, and electrode breakage in the electric arc furnace. The majority of the raw material used in EAF is scrap. It should be selected to obtain the best condition to prepare the basket steel to avoid possible problems in the operating condition. The power consumption during the EAF process is important to optimize the tap-to-tap time. A good basket preparation helps to improve the tap-to-tap time. One, if the possible problem is related to the electrode breakage during the melt operation due to a bad basket preparation. The objectives of this presentation are the one listed in this slide. Identify the different types of steel scrap used to charge the EAF basket and prepare a basket with different scrap. Interpret typical power schedule in the EAF, distinguish the burners and their role in melting process, and outline ways of avoiding the risk of electrode breakage. The EAF is based on recycling steel scrap together with limited addition of alloys in order to reach target composition at tapping. The steel scrap is divided into main types: the internal scrap and the merchant scrap. The internal scrap originates from the different processes within the steel mill and represent the fraction of the product of the produced material that is not part of the final product. In most operations, a small percentage of the treated steel is lost as internal scrap due to safety margins, removal of low quality section, mishandling. The amount of internal scrap varies with the type and numbers of process steps within the mill before the material is shipped to the customer and is reflected by the mill total metal yield. For the merchant scrap, electric steelmaking requires large amounts of scrap, both domestic and imported. The scrap is basically classified according to the properties in the slide: chemical composition of steel, level of impurity elements, physical size and shape, homogeneity. And the high quality scrap is well defined, has a low level of impurities, has a size that has been controlled and or modified by mechanical means. For the raw material preparation, a wide range of raw materials are used in the EAF. Where possible, the lowest cost alternative is selected, so long as the material stays within the chemical composition requirements. In some locations of the furnace, a coarse scrap is not editable, and the more expensive fine scrap should be selected. The finer scrap is used in order to avoid operating problems in the furnace or practical problems when handling the scrap baskets. In this slide, we can see the preparation of the basket raw materials. We have the slag formers that are often loaded into the side of the basket. After charging, they will end up close to the furnace wall. The fine scrap is loaded at the top as it's easier to melt. Light fluffy scrap, such as turning, is loaded at the bottom of the basket, as it cushions the fall and also help prevent finer materials from falling out of the brackets. The slag formers are often loaded into the side of the basket. After charging, they will end up close to the furnace wall. And finally, the coarse scrap that is best located into the center of the basket. The melting stage in the EAF starts when the operator switches the furnace power on after charging the first basket. From that point and onwards, the operating conditions of the EAF change throughout the heat, starting with the melting of cold scrap and ending with the superheated liquid steel at a temperature above 1650 centigrades. By adjusting the transformer tap setting, the operator may adjust the power input according to the present operating condition. By adjusting the furnace secondary voltage, the arc length is changed to obtain optimum operating condition. For the power cycles during melting, the maximum power is utilized for the main part of the meltdown periods. Reduced power is used during the initial stages after scrap basket charging, when the arcs are closed to the delta section of the furnace roof, and during the refining period when operating under flat conditions in order to reach the target temperature. For the tap-to-tap time, the EAF process operation tap-to-tap is divided in two main sections that are described in this slide: the power on and the power off. For the distribution of thermal load, an AC furnace has a triangular setup of the electrodes when viewed from above. In addition, the electromagnetic forces from the arc cause them to deflect outwards from the center. This results in an imbalanced thermal load on the furnace wall will be heavily exposed to the arc radiation. In an effort to even out the thermal imbalance in the furnace, burners may be introduced in areas of low thermal load. The burners will increase the total energy input into the furnace by heating in the cold spots, as well as even out the temperature differences by means of convection. For the burners, a typical EAF burner used gas, fuel or oil, and it's only effective as long as the flames impinge the scrap. Although this results in a relatively short on time, the energy addition is sufficient to even out the thermal imbalance to a large extent. The final argument, the final objective of this lecture is the electrode breakage that occurs occasionally in the EAF, predominantly during the meltdown operation. This should be avoided due to the high cost associated with the breakage. Besides the cost for the high-density graphite electrode, the downtime equals loss of production, which represent high values. Normally, a broken electrode is changed within 10 minutes, but in difficult cases, considerably longer downtimes can be expected. We have two breakage form, and here we have the scrap falling, and we can see this type of breakage with this video. The scrap is caving in from the side as the electrode penetrates into the scrap pile inside the furnace. If heavy pieces hit directly on the electrode side, breakage may occur. The other type of breakage is the scrap obstacle. We can see it with this video. Okay, the electrodes are moving downwards without detecting that a non-conducting material is present at the tip of the electrode. As the electrode continues to push downwards, breakage may occur. And in the end, the combination of arc length and scrap material is also of importance when considering the probability of an electrode breakage.